Find the linear approximation of g of x equals fifth root of 1 plus x at x equals 0 or a equals 0, and use it to approximate the fifth root of 0.95. So we're going to need, for L of x, we're going to need the slope and the point that we're going to use. So g prime of x is going to be 1/5 1 plus x to the -4/5. And we're going to get the slope by evaluating it at 0 here. So m will be equal to 1/5. And the point will just be g of 0, which it looks like it's just 1. So the point is 0, 1, which means we have the equation of the line already in slope-intercept form. So 1/5 x plus 1 is, I guess, my linearization near that point. So now what I have to pay attention to, which is what I forgot to do earlier, is that I did the linearization near 0, not near 1. So g of x, remember, was the fifth root of 1 plus x. It was a function of x, but it was 1 plus x. So if I am trying to approximate the square root of 0.95, I have to see how I can get 0.95 with this original function that I started with, because my linearization again was near 0. So on the inside of my function, I'm always adding 1 to whatever the input is. I guess to get 0.95, I really am looking at, I guess I'll take away a 0.05 to be able to get this fifth root ultimately. So in order to really approximate fifth root of 0.95, because my linearization was not around 1, it was around 0, I'm really looking at an input of -0.05. So what I'm trying to approximate is really, I'm trying to approximate L of -0.05, because remember, L of x is approximately g of x near 0. So what I should really be looking at here is L of -0.05. If I look at just L of 0.95, then I'm really looking at adding 1 to that and going out to 1.95. So when I use my linearization, which is right here, this function, I'm going to look at 1/5 -0.05 plus 1, which is going to give me like 0.99. So again, when I used my linearization approximation, I had to see what the input was for my function to be able to get to 0.95. If I do an input of 0.95, since again the linearization was around 0, I'm really looking at 1 plus 0.95. So in here, I shouldn't be inputting 0.95, but rather -0.05 to be able to achieve that 0.95 approximation due to the function being a 1 plus x. Which makes sense, because the actual function, if I do square root of or fifth root of 0.95, I'm going to get something like if you punch that in, 0.9897 ... And using the linearization, and this L of -0.05 actually leads me to an approximation to the fifth root of 0.95. We got 0.99, which, as you can tell, is fairly close to the actual value.